Alright, so in this video, we're going to be going over some more problems with derivatives with polar equations, okay? So we have our first problem up on the board here. Find any horizontal or vertical tangents for r equals 3 cosine theta. So, okay, the first thing we need to do is take the derivative, okay? We need to take the derivative. This is going to be very similar to parametric equations, okay? Now, our formula, of course, is dr d theta times sine theta plus r cosine theta over dr d theta cosine theta minus r sine theta. We can find our dr d theta and just plug that in. Okay, well, dr d theta is just going to be negative 3 sine theta, right? We can write that down over here. Dr d theta will be negative 3 sine theta. And we don't need to do any more work on the side like we did in the last video because we're not plugging in a point, okay? So we know what our dr d theta is, so our dy dx is going to be equal to negative 3 sine theta times sine theta plus r, which is 3 cosine theta, times cosine theta all over dr d theta again, that's negative 3 sine theta, then we have our cosine theta there too, minus r, which is 3 cosine theta, and then we'll have a sine theta there. Okay, now the first thing that we need to do, right, is find out where the top and bottom are going to be 0, okay? That's the whole point, right? That's exactly how we did it for parametric equations. Okay, so it's going to be the same thing here. So we need to find out where the top is going to be 0, so let's try to find that. We get that negative 3 sine squared theta plus 3 cosine squared theta is going to equal 0. All right, we're going to set that equal to 0 and see what thetas we're going to be dealing with here. Now, to make this a little simpler to look at, what we can do is take out a 3 here. Okay, so if we take out a 3, or we write cosine first, we'll get 3 times cosine squared of theta minus sine squared theta equals 0. And why do we do that? Well, cosine squared minus sine squared is cosine of 2 theta. So now we kind of narrow it down to just this one trig function that we're dealing with. Okay, so really we're just trying to figure out where cosine of 2 theta is 0. We can divide this 3 off. We don't need to worry about it at all. So where will cosine of 2 theta equal 0? Well, where is cosine 0 anyway? Well, 2 theta would have to equal, pi over 2 or 3 pi over 2, okay? And how can we get it there? Well, we can just kind of write that out. 2 theta equals pi over 2. Okay, you divide by 2 on both sides. You know that one of the angles that we're going to be looking at is pi over 4. Okay, the other one, 2 theta equals 3 pi over 2. Divide by 2 on both sides, and you're going to get that that's equal to 3 pi over 4. So now you have 2 places where you're going to have your numerator be 0. Okay, so now we need to do the same exact thing, but for the denominator. Okay, so we need to find out where negative 3 sine theta cosine theta minus 3, again, sine theta cosine theta is equal to 0. Now, what you'll notice here, right, is if anything is 0, right, if sine of theta is 0, then this whole thing becomes 0 because, of course, there's a sine theta here too. And if cosine theta is 0, well, then the whole thing, again, is just going to become 0 because you have a cosine theta here as well. Okay, so you'll get like a 0 minus 0, something like that. So not only do we want to find where sine of theta is 0, but we also want to find where cosine of theta is 0. And those angles are just going to be 0, pi over 2, pi, and 3 pi over 2. Alright, so now you have 4 different angles, and none of these are the same as the pi over 4 and 3 pi over 4 for our horizontal tangents, right, where our numerator is 0. So we know that these are going to be horizontal tangents, and these are going to be vertical tangents, okay? If there was copies, right, then we would need to do some other stuff, which you'll see probably in the next video. Okay, so we have our angles now. All we have to do now is just find r values for them. All right, so here I made a table, and we can find the r values now, and then we can just write out what our horizontal, where we have a horizontal tangent and where we have a vertical tangent. Okay, so first off, when theta is equal to pi over 4, what is r going to be equal to? Okay, we can start off here. R equals 3 cosine of pi over 4. Well, pi over 4, cosine of pi over 4, that's just rad 2 over 2. So we get an r of 3 rad 2 over 2. Okay, what about, so that's 3 rad 2 over 2. Okay, and that's our first horizontal tangent. So we get 3 rad 2 over 2, comma, this will be pi over 4. Next, what about 3 pi over 4? Okay, well, when you plug in 3 pi over 4 in, you're talking about 135 degrees. Talking about the second quadrant, cosine is not positive in the second quadrant, so you're just going to have negative 3 rad 2 over 2. So you'll have negative 3 rad 2 over 2, comma 3 pi over 4. For our vertical tangents, what about when you plug in 0 here? If you plug in 0, 3 cosine of 0, you're just going to get 3. So you get a vertical tangent at 3 comma 0. Next, what about pi over 2? Well, that's going to be, cosine is going to be 0 there, so you'll get a 0 here. You'll also get a 0 at 3 pi over 2. Okay, so that just means that you'll have 2 more points that you can talk about, which is 0 comma pi over 2 and 0 comma 3 pi over 2. And we have our last point here. What about when we plug in pi? When we plug in pi, r equals 3 cosine of pi. We know that cosine of pi is going to be negative 1, so we'll get an r of negative 3. So we're going to get negative 3 comma pi. Alright, and that finishes us off for our horizontal tangents and our vertical tangents, okay? So that's basically it. I mean, it's definitely a decent amount of work, alright, but it's 100% doable, okay? So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for derivatives with polar, and the next video in the series. See you soon.